Hi everybody, I am Sir Alden P. Ensio, your grade 9 mathematics teacher. For today's session, we're going to discuss about simplifying radical expressions. Are you ready? If you are, just sit back, relax, and enjoy learning mathematics. There are certain techniques in simplifying radical expressions. First, we can simplify non-perfect and perfect nth roots by removing perfect nth powers. Second is by reducing the index to the lowest possible order. And lastly, by rationalizing the denominator of the radicand. But for now, we will talk about simplifying radical expressions with non-perfect nth roots by removing perfect nth powers. For starters, let's identify the difference between perfect nth root and non-perfect nth root. Perfect nth root are those radical expressions that does have a perfect nth root. For example, square root of 64, square root of g squared, the cube root of 8, the cube root of 125k raised to the power of 6. Take note that we can easily simplify them as long as you memorize the perfect nth root charts. While non-perfect nth root are those radical expressions that does not have a perfect nth root. For example, square root of 45, square root of x cubed, square root of 25x, and square root of 50x cubed. The question is, how do we simplify them? All you need to do is to factor out the radicand to perfect and non-perfect nth powers and apply the property the nth root of AB is equal to nth root of A times the nth root of B. For example number 1, we have square root of 45. The first step is to identify the perfect square factor of the given radical expression, which is 45. The perfect square factors are square root of 9 and square root of 5. The next step will be extracting the perfect nth root, and that is square root of 9. Square root of 9 is the same as 3. Therefore, the final answer is 3 square root of 5. Example number 2 is the square root of x cubed. The first step is to identify the perfect square factor of x cubed. The factors are the square root of x squared and the square root of x. The second step is extracting the perfect nth root of the square root of x squared. The square root of x squared is equal to x. We therefore conclude that the final answer is x square root of x. Example number 3 is the square root of 25x. The first step is to identify the perfect square factor of 25x. The factors are the square root of 25 and square root of x. The next step is extracting the perfect nth root of square root of 25. And that is the same as 5. Therefore, the final answer is 5 square root of x. Example number 4 is the square root of 50x cubed. The first step is to identify the perfect square factor of 50x cubed. For the factors of numerical coefficient 50, we have the square root of 25 and square root of 2. On the other hand, the factors of x cubed are the square root of x squared and square root of x. The next step will be extracting the perfect nth root of square root of 25, which is 5, and square root of x squared, which is equal to x. The last step will be reorganizing and combining like terms. Therefore, the final answer is 5x square root of 2x. Example number 5 is the cube root of 40, z raised to the power of 7, and y raised to the power of 9. The first step is to identify the perfect cube factor of 40, z raised to the power of 7, y raised to the power of 9. For the factors of numerical coefficient 40, we have the cube root of 8 and the cube root of 5. The factors of z raised to the power of 7 are the cube root of z raised to the power of 6 and the cube root of z. Since cube root of y raised to the power of 9 is a perfect nth root, we will just bring it down. The next step is extracting the perfect nth root of the cube root of 8, which is 2, the cube root of z raised to the power of 6, which is z squared, and the cube root of y raised to the power of 9, which is y cubed. The last step will be reorganizing and combining like terms. Therefore, the final answer is 2z squared y cubed and the cube root of 5z. Take note that the simplified form of a radical expression would require no prime factor of a radicand that has an exponent equal to or greater than the index. Number 1 is square root of 48. 30 seconds starts now. Times up. Example number 2 is the square root of a raised to the power of 7. 30 seconds starts now. Times up. Number 3 is the square root of 81b.
30 seconds starts now.
Time's up. Number 4 is square root of 80 e raised to power of 5.
1 minute starts now.
Time's up. Number 5 is the cube root of 250a raised to the power of 10 b raised to the power of 12.
1 minute starts now.
Time's up. That concludes our session. I hope you learned something from this video lesson. See you again! For clarification and queries, You can contact or email me on my Facebook and Gmail accounts.